All right, so then let's try that on C as well. So if I go use this loop going around here, I would say log base what? 10 of 1 is equal to 0. Now, just one of the weird things about logarithmic equations is that if it's a base 10, you don't have to write the base. Honestly, I don't get ticky-tack about this. I like to have a base in there myself. You could write that like this, because you know how if there's like no number out front of something, we say the understood coefficient is 1? It's like that with log bases. The understood log base is 10. I don't care which form you put it in, honestly. What we are going to talk about is the log base E in a little bit. That's definitely something we're going to talk about. But for right now, just being able to write going one form to another. Right now, this seems super pointless. This is actually a method of solving, and we'll see that in just a second. But right now, I just want to get you comfortable with switching. So now using that same idea, going from a log to an exponential, you just use that same loop trick here, going around from the base there. So to switch it into an exponential form, the exponential starts with the base. So what would be the base that I would start with in A? 3 to what power? The fourth is equal to the third number, 81. Any log can be switched into an exponential and vice versa. So then I would use the same on B. I would start with base what? 1/2 to the -1 is equal to 2. This is easy enough that I would hope for like a bunch of questions like this. Quiz or test. All right, and then the third one, walking around this way, I would say base what? To the is equal to 1. Any issues so far with that? Like I said, we'll see kind of the point of that in a second. I'm going to come back to the graphing question, and let's talk about the bottom example 4 here so that you can kind of see the point of it. Right now, if you were asked to simplify any of these without a calculator, it's not necessarily something you would know how to do, and that's where we use what we just talked about. So on something like this, if I am looking at A, kind of walk through this with me, I don't know what this is equal to, so I'm going to say it's equal to X, just to give it a placeholder. If there is no base written on the log, what did we just say the base is understood to be? 10. So I'm going to fill that in. Now, one thing about this, and the reason we really learn to switch back and forth, is because we don't do logs in our head. That's not something we're taught how to do. We're taught how to do square roots in our head. We're taught how to do exponents in our head, but we are not taught to do logs in our head. So anytime you have a log and you need to solve it by hand, typically we're going to switch it into an exponential. So use that same idea right now, and let's switch this into exponential form. So that's why I need that X there as a placeholder, because I need something to use when I rewrite this. I'm going to rewrite this as base what? 10 to the X power is equal to 100. Now, I know enough about exponents to think this through and say 10 to what power gives me 100? Not, it's 10 times 10, but 10 to what power? The 2. So that tells me X is equal to 2. What that tells me is log base 10 of 100 is equal to 2, because that's where I put that X, right? So you're thinking through what power, 10 to what power gives me 100. Does that make sense? Yeah, we're just quiet. It's Monday after Halloween. All right, now, the other understood base is the one that we see in B. We see the ln. Does anyone remember what ln means the same as? Log base E. So if you need to rewrite this, log base E of 1 is equal to something. We don't know what that something is. All right, so if I rewrite this in exponential form, using my loop to rewrite, I'm going to rewrite it as base what? E to the X power equals 1. Now, I don't know a whole lot about E powers. We did talk about E is about 2.718, but I do know that one of my exponent rules is anything to the what power equals 1? 0. So I know that that has to be a 0. Okay? So I'm going to remember that anything to the 0 power is 1. What that also tells me by extension is the log base anything of 1. Let me write that down up here. Log base anything of 1 is always equal to 0 because of that exponent rule. So I don't even have to switch that one if I don't want to think about it. All right. That also tells me that ln and e are inverses of each other. So it makes some other questions like D kind of easy. If I see ln and e together like this, anyone remember what happens with those? They cancel out. Since those cancel out, that just gives me what? -1. Yeah, I know I skipped C. I'm kind of coming back to it. C has that understood base what again? 10. So if I think log base 10, and I don't know what it's equal to, so I'll call it x, we're going to rewrite this. And this is going to take a minute to rewrite. That's okay. So rewriting this in exponential form will look like what? 10 raised to the x power is equal to 0.1. Now, 0.1, we don't like decimals a whole lot. We don't like fractions a whole lot either, but we can think about fractions a little easier. Anyone know what 0.1 is as a fraction? 1/10. Okay, so I convert that decimal to a fraction. Now, I ask myself, what kind of exponents take a base 10 and make it 1/10? Anyone remember? Negative exponents. So what exponent right there would make it 1/10? -1. Good. And last but not least, e. If I don't know what it's equal to, I make it equal to x, and I rewrite this in exponential form. This would turn into 36 to what power equals 6. Now, we often don't think about these as powers. What's one way I can take a 36 and make it into a 6? Square roots. Yeah, the square root of 36 is equal to 6. Well, does anyone remember what a square root looks like as an exponent? 1/2. Yep. A 1/2 power is the same as a square root. Okay? So this could be stuff that might end up non-calculator-ish. Okay? Some of them would be more basic than others. Some of them I think are a little bit eh. Things like A and B I would consider to be pretty straightforward. And D. I'd like us to be able to do E, but eh. I skipped 3, and I'm coming back to doing the graphing the logs real quick. Okay? And that is the extent of 4.2, which is why I said I was going to cover 2 sections today, because that's super quick. When we do log graphing, it's just the opposite of exponential graphing. So let's take a quick review of our exponential graphing that we did last class. When we did the exponential graphs, we said we had the basic equation for our exponential graph was a times b to the x power, and then we had the whole like plus or minus h, plus or minus k for the up and down and all that. We said for an exponential graph, the first point is 0a. The second point was 1a times b, right? So log graphs work almost exactly the same way, but they are the inverse of them, which means the x's and the y's flip. So on example 3, a log graph is set up basically as a times the log base b, and then you'd have your x minus h, and then your plus k out here. Kind of ran that into my exponential graph, sorry. What that means for us with a log graph is that the first point, instead of being 0a, is a comma 0. The second point, instead of being 1a times b, is a times b 1. And this is going to be basically a sideways exponential function. Now, the one thing with the log functions, and you'll see this if you look ahead at the homework too, is that the a value is typically 1 all the time. Okay, I just use the a to kind of compare it to the exponential so that you know where it's coming from. But what you will see almost all the time is that this a value out front is going to be 1. I've rarely seen it as a number. Okay, so really with logs, if you want to simplify it, the first point tends to always be 1, 0. The second point is then the base, in this case 2, 1. Now, we also remember maybe with exponential graphs that they had an asymptote at y equals 0. A log graph starts with an asymptote at x equals 0. So I have a vertical asymptote for these. So I'm going to draw in my vertical asymptote at 0. That red's kind of hard to see there. And I'm going to draw in a point at 1, 0. And I'm going to draw in a point at 2, 1. And my log graph is going to go kind of sideways compared to the exponential graphs. And it will look like that. We could list a domain and range for this. If you said your domain, what number does it get really close to on the left-hand side here? 0. Does it actually touch 0? No, it goes to 0 with a parentheses out to infinity. What about a range for this one? All real numbers. Now remember that these are inverses of each other, and when we talked about exponentials, we said the domain was all real numbers, and the range you had to find, it flips for the logarithmic graphs. Okay? I feel like I need to give you another example of those, but they're pretty straightforward, honestly. All right, so if we were going to do another example like this, remember our first point is a, comma 0, which in this case your a is what? 1. So my first point would be 1, 0. My second point would be the base and 1. So in this case, what's the base? 3. And then I have 2 transformations on this one, just kind of for the sake of throwing them in there. What is this transformation going to look like on the graph? Left 4. And this transformation is what? Down 2. All right. So if I was to graph this, let's take a look at what that's going to look like. I would take my point at 1, 0 and my point at 3, 1. And I would move both of those points left 4. So left 1, 2, 3, 4, down 2. That first point would land there. Second point, left 4, down 2 would land here. Which one of those is going to move the asymptote this time? The left 4 or the down 2? The left, right? Because what kind of asymptote do I have on a log graph? Vertical. So think about a vertical line. Does up and down move a vertical line, or does left and right move a vertical line? Left, right? So that left 4 moves that here. Okay? So this is very similar to the exponential graphing, just kind of sideways. Now, real quick, one other thing, I won't do a whole graph of this, but if you had something like this, we talked about this already, but just to review, ln is log base what? E, okay? So remember we did the E graphing when we did exponentials? What was E about? 2.7-ish, right? So if I was to make my first points, and I won't do the transformations on this, what would be my first points for this graph? 1, 0, because my A value is 1. What would be my second point? 2.7-ish and 1, and then you would move them left 3, up 1. Any issues with that kind of stuff? Is this familiar to us a little bit? Or are we just dead the day after Thanksgiving? It's not Thanksgiving. I'm ready for that. Halloween. We're here. We're alive. It's good. We were all up late. Okay, let's look at 4.2. Or 4.3. That's what I'm looking at. Yay. All right, 4.3 is where we like to do lots of stuff with expanding and condensing logs and all of that good stuff. And I'm going to cut homework down, so just like hold until I decide what we're going to do with that. Okay? All right, so logs have all these properties. This is always where we kind of like groaned in Algebra 2 because we didn't love them so much. And in fact, for the purposes of what we are going to do, I'm going to go ahead and skip any expanding, okay? Because I don't believe expanding does not help us to solve in all reality. Condensing and being able to simplify some basics will help us. But to solve, we just need to be able to do more of the basic stuff, okay? So let's stick with mostly example 2, and we will just not worry so much about the other stuff. So our log properties above say that we can take a log of 2 things that are multiplied. And if you remember these log properties from Algebra 2 and pre-calc. They work both directions. So I can take the log of two things that are multiplied and I can expand it to two logs that are being added. Or I can take two logs that are being added and condense them to one log where it's multiplied. Division is the exact opposite. Divided by expands to two logs that are being subtracted, or condense two logs that are being subtracted to one log that's being divided. This third rule tells us if we have a log to an exponent, we can bring that exponent down front. Or if you have a number out front of a log, you can bring it back as an exponent, is basically what that says. I would not worry so much about this rule right here. This top right one is that same thing I wrote on the first example, or the first page where I said the log base anything of 1 is equal to 0. That's a good one to know. Log base b of b, so in other words, if these two numbers match, the answer is going to be 1 every time. And then we do not need this last one either. Okay. Now again, today, simplifying the logs like this is going to seem a little bit pointless because it's just going to feel like we are messing with numbers just to make you do something stupid. I get that. But we are going to use it to solve next class, and that's going to be the main point of it. So you kind of need to do a little manipulation before you can actually solve. My main point is going to be the solving, and that's next class. So you just need to know enough for that. All right? So let's take a look at example 2, because in all honesty, everything in example 1 is just expanding things out. And like I said, there's not really a whole lot of point until you get way later into calculus with that. We're not going to get to that this year, so I'm just not worried about it. So just walking through a few of these things to help us simplify. When we see something like A, I do want you to recognize something that we saw in the first lesson, and that is that ln and E are inverses of each other, which means they do what? They cancel. So that means anytime I see an ln and E together in that form, or you could see an E to the ln of something, that's always going to cancel as well. That's just a separate example. Okay? So what would be my answer in A then? 3x. Yes, sir?
So if I saw like a log base of 10, would that also cancel?
A log base, yep, a log by itself, base 10, yes. And that's what we're going to use in B. Good transition there.
Okay.
So in B, we have two logs that are being added. So what does that look most like in the box above? The first rule, right? So the first rule says if I have two logs that are being added, I can condense that down to one log and do what with the pieces? Multiply. So that's multiplying this 1 by this 1,000. What's 1 times 1,000? 1,000. Great. Now, this combines with what we just did on the previous one. I want to simplify this as far as I can. And what is the understood base here that's not written? Base 10. So on the last one, we just did a couple examples like this. If I don't know what this works out to, my best bet is to say that it is equal to x and try to switch it into exponential form. So if I switch this into exponential form, that's going to be what? 10 to the x is equal to 1,000. Now this is a little bit bigger than the last one we talked about on the previous one. We said 10 squared gives me 100. 10 to what power gives me 1,000? 3. So the answer to this entire question is 3. So there is some solving in here just to kind of help us work through it. All right? In C, there's a lot of numbers in C. I'll be honest. There's like a 9th root all involved in this. It's lovely. Anyone remember how we can rewrite roots as exponents? As fractions, right? A square root is a 1/2, so a 9th root is what? 1/9. So the first thing I'm going to do is rewrite this as log base 7 of 7 to the 8th, and I'm going to take that to the 1/9 power, because I prefer that to a root. Now, does anyone remember what we can do with exponents when they're like that, where we have something to the power to a power? What can I do with these two exponents? Multiply them. Okay? So what is an 8 times 1/9? 8/9. So I've got log base 7 of 7 to the 8/9. Are we all okay up to that point? All right, now we have a rule that's going to help us here above. Okay, I see down here what? Log base 7 of 7. Okay, that's going to equal 1. How do I know that's going to equal 1? Because that rule in the top middle, the right middle one, log base b of b equals 1. Right? So log base 7 of 7 is equal to 1, which means that whole thing changes to 1 to the 8/9 power. What's 1 to any power? 1. So with a little manipulation, we can work through to a final answer. We love exponents, and that's what gets us about this, is that our exponent rules are not our favorites. Okay? Now D, we're going to work through with all sorts of fun bases here. What does D look the most like? Which rule? The second on the left, right? What is our rule for division? Okay, so I can separate this into two logs. The log base 3 of 27 minus the log base 3 of what? 81. Now, I'm going to point us back to B. If I don't know how to simplify a log, I take it like I did in B and I switch it into exponential form. Okay? Now this time I have two logs, but let's just handle one at a time. Okay? So let's look at this one. If I don't know what that simplifies to, pretend it's equal to x in your head and switch it into exponential form. What would this look like as an exponential? 3 to the x is equal to 27. Does that help us simplify? 3 to what power gives me 27? 3, right? So that tells me what? Everything in that box is equal to what? 3. Now let's do that with the second one. Same thing with the log base 3 of 81. I'm going to switch that into exponential form. That's going to say 3 to what power gives me 81? 4. So everything in that orange box turns into 4. What's the final thing that I do here? Subtract. So my final answer is -1. And last example. I really can cover 4-2 and 4-3 together. Look at this. It's only 20 minutes. All right, what do we know about ln and e? They cancel. What does that leave me there if they cancel? 1. Good, because it leaves you the exponent. If there's no exponent written on the e, it's an understood 1. Now, I've got to kind of do some side stuff here and deal with the log of 1/10. All right, so that one has an understood base. What's the understood base? 10. So let's switch that into exponential form. Okay? 10 to what power gives me 1/10? We just did that on the previous page, didn't we? -1. All right, so that entire thing simplifies to -1. And what am I supposed to do with those two things? Add them, which means my final answer is what? 0. Good. All right, now